We got some Kaiser University students and helping us today. Awesome. All of these gotta go out. Okay, I want to thank all of you. This is Kaiser University Propeller Club, and you guys have volunteered to help us remove stuff off the boat that we need to remove in order to do the stability test tomorrow, which Jake, our nautical engineer, is going to explain. Okay, Jake, hello. You are from where?
The Jean de la Bay Naval Architects.
Okay.
They're here in town.
And what are we doing?
All right, so what we're doing is we're setting the boat up to do a stability test. So what do we get from doing the stability test? There's 3 key pieces of information we're looking for. As a boat that carries passengers, the boat is issued a stability letter. It comes from the Coast Guard. On that letter is what the lightship of the boat is. That's how much the boat weighs. There's a longitudinal center of gravity and a vertical center of gravity. So the test that we're performing is going to get us those 3 pieces of information. The stability test is broken up into a couple different parts, but the principles are pretty straightforward. So first part is we're going to go all the way around the boat and take measurements that go from the main deck down to the water. That's called your freeboard. Since we know the shape of the boat, we know the shape of the hull, because we have a lines plan and things like that. Based on those measurements, we can determine exactly how much water the boat is displacing. So that equals exactly how much the boat weighs at the time we're doing the test. So that gives us that one key piece of information, the weight of the boat. We know the shape of the water. Since we know the shape of the water, we can also calculate out very easily where that longitudinal center of gravity is for the boat, because it's just the center of the volume of the displaced volume. So then these drums that you're filling up over here, those are our incline weights. And what those are going to do is help us heel the boat port and starboard. And since we know exactly how much weight we have, we're going to actually weigh the drums. Since we know exactly how much weight we have, we're going to be moving them back and forth across the boat and how far we've moved it. So that's our heeling moment. Since we know that, and we know the weight of the boat that we just determined from our freeboards, we will have digital protractor setup, which tells us how far the boat's heeled. We'll have a pendulum set up as well. Haven't set that up yet. It'll be about 13 feet long. So we're going to get that to deflect 6 inches in each direction. But based on the length of the pendulum and how far it deflects, we're going to know exactly to what angle we've heeled the boat each direction. From those key pieces of information, we can then calculate out what the center of gravity of the boat is, the vertical center of gravity. So there's your pieces of information. But to get all of that, it requires setting up the boat, removing all the extraneous weight, putting all these drums on board, setting up a pendulum, setting up our digital protractors. So it's quite the process, but at the end of the day, we'll have all the pieces of information we need to go on that very critical stability.
And we help, all of you are helping with that process. Thank you.
Yeah.
Jake, why are we filling these barrels, please?
These are our incline weights. These are the weights we're going to be moving back and forth across the boat.
Okay.
And it's important that we accurately log the weight of each one, or know exactly how much they weigh, because at the end of the day, that is our incline moment that goes into our calculations.
Gotcha.